Hello, welcome to the implementation of GOAP. Originally, I wanted to give you an overview about real-life planning examples in this video, but since I only wanted to give some reasoning behind specific implementation details and didn't really want to break down strips or fierce GOAP system in a very distorted, simplified version, explaining the examples wouldn't really be of any value. That's why I'll explain some reasoning about specific implementation details in this video, and give you some advice about optimizations, extensions, etc. in the next and last video of this series. That being said, in this video I will first implement the algorithm and the generic abstract stuff you need for it, and then I will implement the RPG oven example I talked about in the last video to show you how to actually use this. Let's get into coding. So I chose C# for this tutorial since a strongly typed language will most certainly give you a better understanding of what's going on. Let's start by implementing our goals. This is just what I said in the last video, nothing changed. So let's make it an abstract class called plan goal. It needs a public name just for debug purposes, and import system, a value, and a float value for how much it changes over time. Change over time. Then just a quality of life constructor which sets value and change over time. And lastly, a method for getting the discontentment. So public float get discontentment. And this will also take in the current value or the new value of the goal. And for now we will just return the value here. Next thing we need are the plan actions. So let's make an abstract class for that. Plan action. How do we actually represent those actions? Well, in my opinion, a functional representation is good enough for most cases. And actually, I haven't used anything different than a functional representation. So what does this do here? This action here is basically just a reference to a method in your code, which can be called and returns us a void, so returns nothing really. So we basically save a reference to a method which will later then be called in each of our plan action objects. Okay, then we also need a duration, which will just be a float, and a method for getting that duration. So public virtual float get duration. This will also be a virtual method, so we can change the way it's calculated later. If you didn't want your action representation to be functional, you would basically have to create another class for the representation, which is then later interpreted by a character. And in my opinion, this just makes it unnecessarily complicated, so just stick with the functional approach. Okay, let's now create the world model. If you already have a world model in your code, it's probably not a good idea to create another one, since you would have to maintain both. What you should do instead is incorporate the code, which I will show you in a moment, into your already existing world model. So, on the other hand, if you don't already have a world model, it's probably a good idea to create one, because if you want good AI, it needs some kind of understanding of it in one way or another, and a world model is an excellent abstraction for that. Let's start. This will be another abstract class called plan world model. The main purpose of this world model will be having a list of all possible actions available for your character, which you can take right now. For the GOAP algorithm later, we will get each action one by one and have the world model keep track of what action it has already given out. By outsourcing this to each world model object, we can save ourselves the headache of managing a list of lists of actions in the planner later. So put in simple terms, the world model will be telling the planner which action it can do next. This will make more sense when we actually implement it, so don't worry about it too much for now. Just know that we are doing the action pointer stuff and so on for that mechanic. Okay, let's now start by implementing the fields. So we need a list of plan actions for our possible actions, and just make this a new empty list. Also use the collections, or implement the collections, use them, whatever. Then we need a list of plan goals called goals, and this will just be a new empty list of plan goals as well. Then another float for the time passed in this specific world model, and lastly a bool for actions discovered. Now what we are doing here is we only want to create this list of possible actions when we actually need it, leaving us the freedom to edit the world model as we please, and only showing us the actions, leaving us the freedom to edit the world model before we actually need the actions. So once we discover the actions in this world model, we will set this flag to true. And then the world model will be ready to give out the actions to the planner. Okay, then we need a method for applying actions to our world model. And we will create a method for that calling apply, and we will create a method for that and call it apply action, and it will just take in the plan action. And then we also need an abstract method for copying the world model. Again, that's something we need for later. And now, lastly, for the abstract methods, we need a method which just covers our actions. So this is just a method which creates the list of possible actions. Okay. So with that out of the way, let's also we need another method which will be virtual to add a goal. Just take in the plan goal and add it to the list of goals. So this.goals.add goal. Then we need a method for calculating the discontentment. So public virtual float calculate discontentment. We will just do this by summing up all the goal discontentment values. So we will calculate the discontentment by summing up all the goal discontentment values. So let's initialize our return value to 0 and then loop over each plan goal in our world model, which we will call float, which we will call new value. So this will just be another float called new value. So this will just be another float, and we will calculate it by having the goal value and adding the goal change over time multiplied with the time passed in our world model. Then add this new value to our return value. So discontentment plus equals goal.get discontentment for our new value. And lastly, just return the discontentment here. Okay. Now let's actually get to the action getting part. We will firstly need a protected int, which will be our action pointer. So this pointer points to the next action, which we will give out in our list of possible actions. Okay, we need the action pointer for that. And then we want to make a method for getting the next action. So this will be public virtual plan action and just call it get next action. So firstly, we want to check if the actions have already been discovered. If they haven't been discovered yet, we want to discover them and set the flag to true. So this ensures that when we need the first action, we will only then discover the actions. So this ensures that if we need the first action, and only then, we discover the actions. Firstly, check if there's even a next action available. So I will do this by checking if the action pointer is out of bounds. I will check if the action pointer is bigger than the last index of the list, and if so, we will just return null. Otherwise, if there's a next action available, then we will get this action and save it to A. So possible actions index action pointer and increase the action pointer by 1, and then just return A. So again, this will give us the actions one by one. Okay, let's now get to the centerpiece of this algorithm, the planner. First, some reasoning about the code. In the last video I talked about action sequences, and yes, we will try action sequences, but we will only save the first action of the best sequence and return that to our character. If you wanted to save all of the actions and have the character execute them, you would basically have the character check if your action is possible in the current state of world, which is relatively close to generating a world model of the current state of the world. And if you do that anyways, why even bother writing additional code to check your plan? So why are we not saving action sequences and giving those to our player? Well, it's not the best way to go about it in my opinion, since you can save yourself a lot of the headache after each action, and that's precisely what I do. If you wanted to save all of the actions and have the character execute them, you would basically have the character check if your action is possible in the current state of world, which is relatively close to generating a world model of the current state of the world. And if you do that anyways, why even bother writing additional code to check your plan? Also, your plan could already be suboptimal by the time your character wants to execute it and so on. So to make a long story short, just let your character replan after each action. And another thing you might not expect from the last video is that we will implement the planner in an iterative manner, so the depth first search will be iteratively and not recursively, since it's less memory intensive in any case, but in this case especially, because in a recursive solution you would have to return an action with every score and thereby a null action in the base case. So to again make it short, we can do it more elegantly and less memory intensive by writing slightly more complicated code. But if you're interested in the recursive implementation, you can check out the GitHub, which has a recursive implementation. But there's really no reason to use that one in production. And if you look at it, you should do it for exercise purposes. Okay, let's start. Let's make a class called iterative planner. You can just name this planner if you want. So the iterative planner only has one action, and it will be a virtual method and will return us a plain plan action. So let's implement this: public virtual plan action, plan actions, and it takes in a world model, the initial world model, and a max planning depth. Then let's first create an array of world models, call it models, and make it an array of size max depth +1, and set the first of these models to the initial world model. So yeah. Then let's also create an array of plan actions called actions, and make it the size of max depth. So plan action, yeah. Then let's keep track of the best action so far. Plan action, best action equals null for the moment, and the best value, and initialize this to the max value of a single. So this is a discontentment value, and we really want to minimize this, and therefore we have to make it a max value and not a min value. Okay, so now let's get to the part of the depth first search. So I'll keep track of the current depth with an integer, initialize it with 0, then a plan action variable called next action, just for convenience, and a float for the current value. Okay, let's get into the while loop we will use. So while current depth bigger than or equals to 0, get the current value by having the model at the current depth calculate its discontentment. If the current depth is bigger than or equals to the max depth, so we could just do equals, but whatever. So this is the recursion base case, and now let's check if the current value is lower than the best value we already have, and if so, we found a new best plan, and then set best value to current value, and set the best action to the first action in the tested action sequence. Then outside of this if statement, do current depth -1, so we drop down one layer here. Then in the non-base case, or in the recursion case, get in the next action from the world model, from the current world model. So current depth dot get next action. If the next action is available, so if it's not null, then we want to copy this world model we have here into the next layer of our world model sequence. So models current depth plus 1 equals our current world model current depth dot copy, and the actions for the current depth equals the next action. So this is saving the action sequence. Then let's just apply the next action to this newly copied world model. So keep in mind we haven't changed the current depth value yet, so we need to add one here. Apply action, then apply action and give in next action as a parameter. So in the other case, if we have no next action left in this world model, so every action has been tested of one world model, we just drop down one layer again. So current depth -1. So, and that's already it. We just have to return the best action here. Okay, so now that we're done implementing the abstract stuff, let's actually get to our RPG example. What do we need to implement? The goals, the actions, and the world model. Everything else will just stay the same for every application you do. Let us start by implementing the goals. And we only have one goal, which is to maximize our saturation. I will show you how to do that right now. Make a class called saturation goal, class saturation goal, and make it inherit from the plan goal. And then we just need the constructor, but fortunately we don't need to change anything there. So just have your IDE do the stuff and don't change anything. What we actually want to change is to get discontentment. So public override float get discontentment. And I actually forgot to make this virtual. And just return minus the get discontentment, and this takes in a new value, and here just return the new value, negative new value. So remember, what we're doing here is minimizing the discontentment value, and since the saturation will be positive, since saturation can only go up and not be negative, we're doing a kind of a workaround here, since we are making the saturation negative and then we are trying to get it down even further. So in the code we are minimizing a negative value when in actuality we will be maximizing a positive value. If that doesn't make sense right now, just take a moment and think about it. That's kind of a workaround we have to do here, the way I implemented it earlier. Then let's continue with the actions. Firstly, we will need an abstract class, which I will call RPG action, which just inherits from the plan action. And here we will specify every parameter that will matter in our world model and the effect it has on that parameter, to be specific. So, as well as the duration. So in our world model, we have 3 parameters that matter for that simple example. So it's the meat piece change of an action, how our supply of meat pieces changes, how our supply of cooked meat pieces changes, and how our saturation changes. So we firstly have a public int meat piece change and set that to 0, as well as a cooked meat change, a saturation change, which will be a float, and I think we need a constructor here, so public RPG action, which will just set those parameters as well as the duration. So int meat piece change, int cooked meat change, int saturation change, and a float duration, float saturation change. Okay, some quick changes I've forgotten here. We need a constructor for this. So public plan action, which will take in the action and the duration, and we'll just set it here, duration, and this duration here. And for the rest, let's call the base constructor, and it will take in action, and float duration, base action duration. Okay, and that's about it for the abstract RPG action class. And let's now get to the most tedious part, in my opinion, the world model. And I think you will now really get why I said you shouldn't create this twice. But let's start. So public class RPG world, and this inherits from the plan world model. So right off the bat, let's implement those methods we need here. Two more things we need is the parameters. So again, int meat piece change. So int meat pieces, cooked meat, and the saturation, and a boolean to check if it has an oven. Then second thing is a constructor which sets those values again, and it should look something like this. Then I would say let's continue with the copy. So plan world model m or model is just a new RPG world, and actually let's make this another RPG world, and this just takes in this dot meat pieces, the cooked meat, and has oven, and also add all the goals from our world model to a copy. So model.add goal, and what I'm going to do here is really bad code, and you shouldn't do this in production, but since we only have one goal, I'll access the goal list and just choose the first one and copy the values. But in production, you should really iterate over those goals. So new saturation goal, goals, take the first goal and put in its value, and it's change over time. So everything else should be already right. So return the model here. Okay, so now something more straightforward, which is applying the action. It takes in a plan action and basically has the world model interpreted. So what do we actually interpret? Well, firstly the time passed, so time passed plus equals the action time. So get duration here. What we also need to interpret is the RPG specific stuff. What we have to do for that is, even though it's ugly, we have to do a type conversion here. So RPG action equals plan action or action as RPG action. So yeah, I know this is kind of ugly, but it works for this case. And what we can do then is meat pieces change. So, and what we can do now is just change the parameters, and now we can change the stuff we need. So meat pieces plus equals RPG action dot meat piece change, and cooked meat plus equals RPG action dot cooked meat change. Then again, we need to change the saturation goal here. So this is kind of ugly, and again, don't do this in production, but I will do this for the example here. So saturation goal, let's first get it. Set goal, saturation goal equals goals, so the first goal as saturation goal. Again, type conversion, which is ugly. And then saturation goal dot value plus equals RPG action dot saturation change. Then also let's do one special action, which I will call go to oven action, so which will inherit from RPG action, and will just do nothing, but obviously it should do something in your code, which is kind of ugly about this action interpretations. And now we will check if the action is a go to oven action, and if so, we set oven available, so has oven, to true. In production, you could avoid this by having an enum for every action for convenience, clarity, and comfort in programming. So yeah, if action dot get type equals go to oven action dot if action dot get type equals type of go to oven action, then has oven equals true. And that's it for this simple action interpretation. And the last thing we have to do is implement a method for discovering the possible actions in the current world state. And again, this is kind of ugly since we have to interpret the action here. And the last thing we have to do is implement a method for getting the possible actions in the current state of the world. And what we will basically do here is create rules for when to add the actions to the possible actions. So these will just be if statements, and if they're true, then we add a possible action to the list of possible actions. So let's start. So for example, if we don't have an oven yet, we add a go to oven action to our possible actions. So go to oven action, new go to oven action, and this takes in, so new go to oven action, and this takes in a meat piece change 0, cooked meat change 0, saturation change. Well, we can do -2 here, an action which I will just do null since it's not a real game and just an example, and duration, let's say 15 seconds. And if we have an oven, so has oven, and we have at least one raw piece of meat, so raw meat pieces bigger than 0, then we have a cook meat action, so possible actions dot add basic RPG action. So meat piece change -1, cooked meat change 1, so we lose one uncooked meat and get one cooked meat. Saturation change minus, let's say 0.5, an action which will just be null again, and duration, let's say, takes 30 seconds to cook or whatever. And then just the eating action, so if meat pieces bigger than 0, then possible actions dot add a action for eating raw meat, so new RPG action, meat piece change -1, cooked meat change 0, saturation say +5 null, and duration 3 seconds. And lastly, for the cooked meat, so cooked meat bigger than 0, possible actions dot add new RPG action, meat piece change 0, cooked meat change -1, saturation change, let's do 25, so 5 times the amount of raw meat, and time, we should also do 3 seconds here. And that's about it. Obviously, this discover action is highly specific to your personal project, since you are basically just specifying rules about the world and what a character should know about the world. So you need to put some extra thought into this, and this might be a little bit labor intensive, but if you want Gope, it will be worth in the end. So yeah. Now let's actually test if this whole thing works. Okay, I am in Unity right now, and I just came up with this simple test script here. So first we log planning, then we instantiate a new planner, create a world model with 1 raw piece of meat, 0 cooked piece of meat, and no oven, and add a saturation goal with the goal of 50 and change over time -0.5. Then we just let our planner plan the best action with a depth of 3, and then print us out the best. And I just attached that test mono behavior to a random game object, a cube in this example. Let's test it out. And it should print go to oven action, and it does. If this was a greedy approach, then it would have printed us the eat raw piece of meat action. Yeah, that's the effect the planning had on this example. So I've been working on this video for 233 days or 7 months and 19 days straight, and have not been distracted by other stuff. That couldn't have been the case, so a like would be highly appreciated. Also subscribe to my channel for more computer science stuff. I promise the next video will be out sooner. Until then, bye.